Hi everyone, so this is the video on ladder method that I promised. So this is a continuation of the other video, the lineup method if you recall. So now what is the ladder method, you may be wondering. So the ladder method, to me, it's actually a method that you can use to solve for the highest common factors and the lowest common multiples faster. But at the same time, I feel that it is more tricky and more complicated. So I'm going to teach you now, and if you understand it well, fine, then go ahead and use it. Otherwise, I would recommend that you stick to the lineup method as I have taught you in the previous video. So now, without further ado, so let's say we have two numbers, 20 and 50, and we want to use the ladder method to solve for this. Now, we're just going to prime factorize 20 and 50. So, recall that a prime factorization would be dividing the numbers here by the prime number, the lowest prime number possible, that is not 1. So now, we need a prime number that is the lowest possible one, that can be divided by, that 50 and 20 can be divided by. So, in this case, let's pause for a moment. So we realize that 2 is going to be the lowest prime number that can be used to divide these two numbers. So we're going to go ahead and use 2. So what happens is we're going to get 10 and 25. And after this, again, we think about it, the number will be 5, as 10 and 25 both can be divided by 5. So in this case, right now, these two numbers here are already prime numbers. So we should stop here. We should just stop right here. So what happens now is, in this simple case whereby in each step we can divide both numbers by the prime numbers, and at the end we have prime numbers here, it's very simple. We can go about doing as such. What happens is just that the highest common factor will be these two, and the lowest common factors will be these two and these two. What do I mean? So therefore, HCF is 2 times 5. As I said, these two. So this is just going to give us 10. And the LCM will be this, multiplied by this, and this, and this. So this is going to be 2 square times 5 square, and gives us 100. Okay, so this is a simple example, and it seems that the ladder method is very straightforward. So let's move on to a slightly more complicated numbers and see what happens. So let's say we have the numbers 3, 0, 8, and 105. They're really big numbers, and looking at them straight away, we don't know whether there is any prime number that both numbers can be divided by. So it is going to give us a pause straight away. So as you can see, like in cases like this, it is quite difficult because it's hard to see what prime numbers can be used to divide by both these two numbers. So if we do it individually, I believe it will be easier. But okay, let's say we carry on to we want to do them both at the same time using the ladder method. So what happens? After maybe some thought, we realize that 7 is a prime number that can be divided by both these two numbers. So 308 divided by 7 gives us 44, and this gives us 15. Okay, so now take a moment to think about these two numbers. Is there any prime number that we can use to divide by 44 and 15? So the answer is no. There's no prime number that 44 and 15 can be divided by. So we have to take note here and realize that in this case, cases like this, if there's no other prime number, what just happens is that the HCF will be 7. So HCF is equals to 7. And now, how about the LCM? For the LCM, okay, we just go on. But now note that as we go on, we have to do them separately. So when I put a number here, I'll only divide 44 by this number and leave 15 here because both of them can't be divided by the same number. So what happens? It is going to look like this. So it's very important that you realize the HCF is 7 and only 7. And don't get confused by now at the new numbers you can add here. That's why, as I said, ladder method can be a little more tricky. So now what happens is divide by 2 because 44 can be divided by 2. We get 22 and 15. See, 15 remains the same. We're just going to now focus on, let's say, the left number. So 22, again, we can divide by 2. So we get 11 and 15. And then this one will get divided by 11. And gives us 1 and 15. So right now, 1 is settled. And we're going to carry on for the 15 part. So let's say this one will be 3, giving us 1 and 5, and finally 5. 1 and 1. So thus, again, like the first earlier example, recall, we are going to say that the LCM is just simply all these numbers multiplied by these numbers here. So in this case, what would the LCM be? The LCM would be equals to 7 multiplied by 2 square multiplied by 11 multiplied by 3 multiplied by 5, and this would give us 4620. So this will be the answer for this example. I hope that you liked the video and learned something today. And please, if you enjoyed the video, like and subscribe. Thank you.